All right, students, today we are going to go over piecewise function graphs. Before we start, though, I just want to do a quick review over even, odd, or neither functions. If we look at number 1, this is an absolute value function, and this is actually the parent function, and it's symmetric about the y-axis, which means it's going to be an even function. Okay, remember, even functions are symmetric about the y-axis. Number 2. X to the third plus 1. This is a cubic function. The parent function for a cubic function is symmetric about the origin, which would mean it's an odd function. But because we have a transformation, the graph moves up 1. So we're no longer at the origin anymore, which means that there's no symmetry with the origin. So this would be neither because it's not symmetric with the y-axis as well. Number 3, we have a quadratic. Normally these are symmetric with the y-axis. However, this graph is moved around, and it's also not symmetric with the origin, so this would be neither. And lastly, on number 4, log functions. Those are neither symmetric with the x-axis, or I'm sorry, with the y-axis or the origin. So this is neither as well. Okay, there's our little quick even, odd, or neither review. So even, y-axis, odd, origin. Okay? All right, so piecewise divide functions, they're defined by 2 or more rules. Okay, these are the rules right here. Each rule applies to a different part of the domain of the function. So these are the rules, and then here are the domains that we have that are different. Okay? So I like to make little t-charts here to help me figure out if I'm going to have open or closed circles on certain parts. So this is y equals or f of x equals. So we have 3 different equations here. When y equals -3, when y equals x plus 2, and when y equals 2x. So we're going to have 3 different pieces here, hence the word piecewise. Okay? So I'm going to make a little t-chart for each of these, and you don't have to do this every time. I just like to do it in notes just in case people are struggling. So we got x, y, x, y, x, y. Alrighty, so to start, I like to look at my domain. Okay, here my x values start at -2, so that's going to be my first number I put here. There's a line under this inequality sign, so I know I'm going to have a closed circle there. Okay. Now I want x values that are less than -2. Well, what are x values that are less than -2? -3, -4, -5. Okay. And then we're going to go ahead and fill in all those y values. Well, y is -3, so it's going to look like this. All those values will be -3. All right, over here in this equation, we go from -2, I'm sorry, to 3. So -2, I need x values that are greater than that and that are less than 3. So I'm just going to pick like 1 or 2 values. Let's just say 0 and 1. Okay? Those are nice, pretty numbers. And I'm just going to go ahead and plug those in for x and solve those. So -2 plus 2 is 0, 2, 3, and 5. And then on this -2, the inequality is not underlined, so this will be an open circle. And on the 3, it's going to be a closed circle because there's a line under the inequality sign. So this kind of helps me like lay out what my graph will look like. And on the last one, y equals 2x, my x values are greater than 3. I start at 3. There's no line under the inequality, so open circle. And then I need x values greater than 3. 4, 5, and 6. And let's just plug those in. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. All right. So hopefully we're doing okay so far. And now I'm just going to go over here and plot all these points. So -2, -3, -3, -3, -4, -3. All right, as you can see, we have a straight line. I'm going to grab my ruler. Make nice pretty lines. And notice I made this coordinate point, -2, -3, a closed circle right there. So that goes out like that. Then we have negative 2, 0. That's an open circle. So at negative 2, 0, I'm going to place an open circle. Okay? We have 0, 2. 1, 1, 2, 3. And the coordinate point 3, 5 is a closed circle right here. So I'm going to make that a closed circle. And connect these points nice and pretty. Okay, and then my last one, I've got 3, 6, which is an open circle. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Alrighty, and then 4, that's 6, 7, 8, 5, 10, and that's just going to go off into the distance there. Alright, so there's your first piecewise function. Okay, so again, you don't have to make these tables. I personally like making them just to help me figure out when I'm going to have closed and when I'm going to have open circles. Okay, I know sometimes I'll even put like here, these are just all the x values that are less than negative 2. So down here I know I'm going to arrow off. Whereas for this equation, these are all the x values greater than 3. So I'm just going to keep on going forever. So I know I'm going to arrow off there, which you guys can tell on the graph. Alrighty, let's do another example. Number 6. All right, here we have 2 pieces of this function. G of x equals x squared plus 1. G of x equals negative x squared minus 1. Table of values. Okay, from here, we're starting at 0. It's our domain. Okay, it's all the x values that are less than 0. Well, first of all, I know I'm going to have an open circle there, right? And then values that are less than 0, negative 1, negative 2, negative 3. And that's just going to keep going forever. Over here, I start at 0. Again, another open circle because there's no line under the inequality. And it's all the values that are greater than 0. So 1, 2, and 3. And that's just going to keep going on forever. Okay? All right, let's plug in these values and solve this. So 0 squared plus 1 is 1. Let's see, that's 1, so that would be 2. Negative 2 squared is 4 plus 1 is 5. That's 9, so 10. Okay. And then we have over here, 0, that's negative 1. We have 1 squared, which is 1, but that's negative. So negative 1 minus 1 is negative 2. 2 squared is 4, but that's negative 4, so this is negative 5. 3 squared, it's 9. Negative 9 minus 1 is negative 10. Okay, and let's plot these points. So at 0, 1, I'm going to have an open circle. And then negative 1, 2. Negative 2, 5. All right, and it looks like I can't fit the last one on there. So this is a quadratic equation, so I know I need to curve this a little bit. Okay. And then over here, I have 0, negative 1 with an open circle. 1, negative 2. And 2, negative 5. And that's going to close off like that. Again, that's a quadratic. All right. All right, hopefully we're doing good so far. Flip it over to the back. Alrighty. So we've got 2 equations here again. F of x equals x squared minus 1. F of x equals negative 2x. xy, xy. Alrighty. So here, all the x values that are less than 1. So let's see there. We've got 1, values less than 1. 0, negative 1. That's going to be an open circle on the 1. And this just continues on. And then we have over here on this guy, we've got 1. That's going to be a closed circle because of the line underneath. And all the x values that are greater than 1. And that's going to go on forever. Let me just make sure I did that right real quick. X is less than 1 and values that are greater than 1. Okay, good. All right, so if I plug in 1 here, that's going to give me a 0. 0 is negative 1. 1 minus 1 is 0. Okay. Over here, let's see, that's -2, -4, -6. All right, let's plot this guy. So at 1, 0, open circle, 0, -1, -1, 0. That's a little guy. Let's do one more point on there. So what would that be? 4 minus 1 is 3, right? Get a little bit of a better picture. We want to have nice, pretty pictures. All right, and then at 1, -2, we are going to have a closed circle. 2, 1, 2, 3, 4. And that's going to go off into a straight line because it's linear. Again, you don't have to make these tables. Just make sure those first points, you know what's open, what's closed. And then like here on the linear function, you can just use what you know about slopes. Okay, you can just do down to the right one or up to the left one, but you just have to be careful about the restriction on the domain. Okay? All right, last one we've got here. Write the equation of h of x. And h of x is f of x from item 7 reflected over the x-axis. Okay, so we actually need to take a look at this guy right here. So, oh, whoopsies. I also want you guys to draw this. So, let's just make note. Let's say draw h of x. Alright, so h of x is going to equal, first of all, it's only going to have 2 pieces because f of x only had 2 pieces. Oh, you guys can't see that. Let me make that a little bigger. Yeah, right there. Okay, so we need to take all of these 2 pieces from f of x, and we want to reflect it over the x-axis. Okay, a reflection over the x-axis, it means that we would make this negative out in front. Well, when we make that negative out in front like that, so x squared minus 1, okay, that's going to make this negative, and that 1 is going to become positive. So negative x squared plus 1. Okay. We also need to look at and see if it's going to affect our restriction. Here, it will not, because all you're doing is reflecting over the y-axis. You're not moving left or right. The x values aren't changing, okay? And then we have negative 2x, okay? Again, if we reflect that, so negative 2x, that's just going to become positive 2x. Same thing right here. The x values aren't changing, so there's no transformations on the x values, so we don't need to worry about the domain. All right, let's go ahead and graph this now. All right, let's do this one without making the tables. So at 1, when x is 1, I'm going to have an open circle. So if I plug in 1 right there, 1 squared is 1. That's really negative 1. Plus 1 is 0. So this will be 1, 0. Okay, I need x values that are less than 1. So I need to go this direction. So let's plug in a 0 there. That will become 0, 1. If I plug in negative 1, I'm back to 0. And if I plug in a negative 2, that makes a positive 4, but really that's a negative 4 because the negative out in front plus 1 would give me negative 3. So this is my first graph. Okay, and then down here, I need to use that number or that x value of 1 still. 1 times 2 is 2. So 1, 2, and that's going to be a closed circle on that 1 because of the underlined inequality. All right, x values that are greater than 1, so all these x values over here. So if I plug in a 2, 2 times 2 is 4. I also can just use the slope. Okay, so I'm going to go up 2 over 1. So a couple different ways to think about these. Oops. All right, like I said, you can make a table. You don't have to every single time, though. I just wanted to show you guys that. Hopefully that made things pretty clear for you. All right, guys, get started on the homework.